Well, we're finally ready to start the last section in chapter 7, which is 7.6, and we're going to take apart some circles. So we're going to leave the regular polygons and move to circles. And we're going to look at areas of circles, what is a sector of a circle, and what's a segment of a circle. We're used to a segment as a portion of a line. What is a segment in relation to a circle? And how do we measure those things? So we're going to look at that today, and then in the next video we will finish this section. To begin, we'll review what you already know, which is how to find the area of a circle. The area of a circle is found by taking the radius and squaring it, multiplying it by itself, and then multiplying that by pi. Your textbook goes into a lot of detail about how this formula has been derived, which you are free to look at. They all work and they're very interesting, but I'm not going to take the time in this video to go over that. We're just going to learn how to use the formula. So let's start by saying I have a circle whose diameter is 10 inches. So the diameter is 10 inches, so it's a pretty good sized circle. What is the area of this circle? So your first step is to realize I don't want the diameter. In order to find the area, I need the radius. And the diameter is twice the radius. So if I have the diameter, I need to cut that in half to get the radius. So if my diameter is 10 inches, my radius is 5 inches. Be very, very careful when you apply this. Order of operations matters. You must square the radius before multiplying by pi. Do not go pi times the radius and then square your answer. You will be wrong. Order of operations say powers are first. So, first thing to do is to square 5. 5 times 5 is 25. So you're going to take 25 and multiply it by pi. The exact answer for the area of the circle would be 25 pi, because pi is irrational. So you can only approximate if you try to get a number other than that. That's the most precise answer. Look carefully at the problem. Does it ask for the most exact answer or the answer rounded to the nearest whatever place? Use your pi button on the calculator. Don't use 3.14. Use the pi button, multiply 25 by pi, and you will get what this circle would be approximately, or at least it's what its area would be, which is about 78.5 square inches. 78.5 square inches, or whatever the units are, you would take that unit and square it, and that would be the area for that circle. Here's another problem involving a circle. I have a circle with a radius of 2 square root of 2. What is its area and what's its circumference? So the radius is 2 square root of 2. That's what we want to square. How do you square 2 square root of 2? This is a problem that some students have, so let me help you to do that. If I want to square that, think of this 2 as like a coefficient and this 2 as almost a variable. It isn't, but think of it that way. You're going to square both of them individually and then multiply your answer, because it's this 2 times the square root of 2. So you're going to multiply 2 squared times the square root of 2 squared. So 2 squared is 4, and the square root of 2 times the square root of 2 is the square root of 4, or 2. The square undoes the square root, so that ends up being 4 times 2, or 8. So our answer for the area would be 8 times pi, whatever your calculator tells you that is to the nearest hundredth or so. That's the area. Now, I didn't review how to find the circumference. The circumference is double the radius times pi, often written as 2 pi r, or diameter times pi. So the first thing now what we need to do is we need to take this radius and we have to double it. We have to multiply it. And again, how do we multiply this? When you multiply a number that has a whole coefficient in front of a radical, it's number times number, radical times radical. So it's 2 times 2, which is 4. You have 4 square root of 2. This radical is very much treated like a variable would be. If I multiplied 2 times 2x, I'd have 4x. You're multiplying 2 by 2 square root of 2, so you have 4 square root of 2. And then that times pi. And that would be the circumference of this circle. That double the radius times pi. One more practice using the formula for the area of a circle. I have a circle and I know its area. Its area is 7 pi square units, 7 pi. So somebody took the radius and squared that to get 7, because pi times the radius squared ended up being 7 pi. So when you divide out the pi's, you realize that the radius squared was 7. So how do I invert? What's the inverse of squaring? It's the square root. So I'm going to take the square root of both sides, and my radius ends up being the square root of 7. Square root of 7 times square root of 7 is 7. So my radius is the square root of 7. That's how you do that. Now, from that, how do I find the circumference? Again, I take the radius and I double it. So 1 square root of 7 times 2 is 2 square root of 7. So this would be 2 square root of 7. That's what the diameter of that circle would be. And I'm multiplying that times pi, and that gives me the circumference of that circle. Okay, I've taken a circle and I've drawn 2 radii, a radius here and a radius here, and it's sort of like I took my pizza or my pie, my Christmas pie, and I cut a wedge out of it, didn't I? And I created what's called a sector. This is a portion of the circle. This angle that's created by these 2 radiuses right here is called a central angle. And it's a central angle because its vertex is the center of the circle and its 2 sides are 2 radii of the circle. That makes it a central angle. Very often you will see people, when they refer to the measure of an angle, they will use a Greek letter, the theta letter. It looks kind of like this. If you do it by hand, it looks a little bit more like that in typing. So anyway, that you will often see that as a reference to an angle, a variable for an angle. So you could put it here, and that would be the theta angle is that central angle. Just so you recognize that's a common Greek letter to use to reference an angle. This region that I've colored in blue is called a sector of a circle. So by definition, a sector of a circle is the region bound by 2 radii and this intercepted arc. We call it an intercepted arc because that's the portion of the circle that's cut off by those 2 radii. So it's sort of like the crust of your pie or the crust of your pizza, right? That very edge of it is the intercepted arc. My C isn't very clear. There we go. And that whole region is called a sector. And the last term I want to show you is a segment. Remember I said we're going to see a segment of a circle. It's like a portion of a line, only what's a segment of a circle? This green part, that region is called a segment. So it is created by a chord, which is a line connecting 2 points on a circle, and its intercepted arc. So if you think back to the pie or pizza, there we go. Think back to the pie or the pizza. Let's say you like the pizza, but you're not a fan of the crust, so you take the crust off. That would be what we'd call the segment. So the circle, a central angle, really important, a sector, and a segment. These are all portions of circles, so let's work with these. I have taken a circle and made a pie chart out of it, and each portion of a pie chart is a sector of the circle. And I labeled them by percentages. This is somebody's investment portfolio. 45% of their investments are in domestic stocks. That means stocks from United States companies. 30% are from stocks, foreign stocks, so stocks from other countries. Bonds are 20%, government bonds, and then 5% of their money is in cash. All right, what we want to find out is what's the central angle for each one of these sectors, and how much money is in each sector if the total of all of this person's portfolio amounts to $750,000. How do we find this? So the way that we do this is we remember that a circle has a total of 360 degrees. So the percentages that I put in this pie chart is the percent of those 360 degrees. Remember, the keyword of in math always means to multiply. And when you're dealing with percents, you use them in decimal form. So to find the central angle for each sector, you multiply the percentage of the circle times 360 degrees, and that tells you the portion of the circle that is in each sector. Also tells you the measure of the central angle, which is what we want. So here is a list of what we're going to put into our calculator for each category. These are my abbreviations for domestic stocks, foreign stocks, bonds, and cash. And here are their percentages in decimal form. Be really careful when you have small percentages like 5 that you don't put 0.5. Remember, it's 0.05. That's a common mistake. You multiply each one of those percentages by 360. That will give you the measure of the central angles. So I did all 4 of these, and I got these angles are the measures of the central angles. They should add up to exactly 360. Sometimes in circle graphs, sometimes they'll round, and so it can be not exactly 100%, but it should be 100% if you do it right, especially out of a textbook. And there's our central angles. Now, how do we answer the second question? What is the amount of money in each account if the total is $750,000? It's the exact same principle. We realized the total number of degrees was 360, so we found that percentage of 360, so we multiplied it. We do the exact same thing with the total of each category of money. So for the total number of domestic stocks, you would multiply 0.45 times 750,000. You do the same process. It's just instead of 360, it'll be $750,000. That's how you answer that, and you will have 4 different amounts. So I replaced my 4 equations, and in place of 360 degrees, I replaced it with 750,000. That K is abbreviation for 1,000. And there's our answer for how much money he has in each portion of his investment, or hers investment portfolio. And there you have it. So in the next segment, we're going to get into how to find the areas of these sectors and areas of segments, how to work all that out. It would be a little bit much to do it all at once, so we'll do that in the next video. But for now, make sure you understand how to find those central angles, know what a sector is, know what a segment is, and how you work with those relationships. And I will see you guys in the next video.